Okay, so another big mechanism to consider is autoregulation. Autoregulation, as the name implies, is your body's ability to regulate itself. And when we consider cerebral autoregulation, this is a bit more of a specific definition, although there's many different ways to measure this. But cerebral autoregulation is essentially how your cerebral vessels, right, so the blood vessels around your brain, respond to changes in arterial blood pressure. Okay, so how fast or how well is your brain adjusting and adapting in a hemodynamic response specifically to the rest of your systemic responses? And this again is due to some kind of external stressor, so something like a reduction in oxygen in the atmosphere. How is your body adapting to it? And in response to how your body's adapting to it, what kind of changes or adjustments is your brain making as well? So, very simply, we can define that as autoregulation. And quite common, autoregulation and cerebral autoregulation in research is used for areas such as sport-related concussion. So if you take a hit to the head, it kind of throws off your autonomic nervous system. And from there, we tend to measure things like cerebral autoregulation, looking at blood flow, blood pressure, breathing patterns, all these kinds of things, right? And what we tend to find is that your brain isn't able to adjust to the amount of blood pressure change or blood pressure drive that your body's inducing. So we tend to see quite a disruption in cerebral autoregulation if there is some kind of autonomic problem. And hypoxic conditions can often produce some of these types of problems as well, right? Some kind of autonomic disruption, rapid adjustment that's required to occur. So there's a good chance, at least initially, that there are some cerebral autoregulation adaptations that are occurring as well. So some research has shown this as well within the first day or two, or even as early as the first half hour. There are some differences that we see in hypoxia when it comes to autoregulation. But one thing to always keep in mind is in this case is that it's not always an impairment that's occurring initially. Okay, so even if you see changes in autoregulation, it's not necessarily a bad thing. It's just more that your body is trying to figure out how to adjust and adapt to the stress that's around you. And when you go into altitude, of course, the immediate removal or restriction, I should say, in oxygen, it does tend to require a massive adaptation, and it does seem to be something where it takes a bit of time for your body to finally adjust to. An example is over 2 years in Tibet, when you're looking at about 4,400 meters in elevation again. There are adaptations, right, that occur in cerebral autoregulation. So these individuals don't seem to have any different mechanistic responses than individuals who are at sea level, just because they've adapted and adjusted over time. There was a group out in BC who took a look at 1 to 2 days at approximately 5,400 meters in elevation, and they found that there are some quote-unquote impairments, right, that occur in hemodynamic regulation. So cerebral autoregulation from that point between brain blood vessels and blood pressure. But again, this first day or two, there's a good chance that it is a reflection of adaptation. But the research really isn't there at the moment. Like, there's more that has to be done to better understand what's going on. There's also cerebral oxygenation. So how much oxygen is your brain metabolizing? And if we take a look at hypoxia, when oxygen levels again are limited, there are massive differences in this case as well. So, there's more deoxyhemoglobin, so the hemoglobin that doesn't carry oxygen at the brain. And again, the reason being is that there's just not enough oxygen available, right? So it does induce some interesting physiological changes as well. And actually, this deoxygenation parameter, it's something that we found here in our lab as well when we put people for 30 minutes in about 14 to 15% oxygen. There's a pretty immediate increase in deoxygenated hemoglobin, I should say, compared to when you're outside of hypoxic conditions. Awesome. So this was a recent trip that I took to Banff, and I don't know how many of you have been there, but this picture in the back is of Lake Agnes. It's, not too high up, roughly 2,500 meters in elevation, so it took us about an hour or so to get up there. But we kept going all the way up, and I don't even know where we ended up. Um, but this was maybe about the halfway point. So, it's an amazing place. There's so many different hikes, mountains, lakes, and so on, and we tried, to see as much as we can, although we were only out there for about a day or so. Um, as you can see from the picture, it's an unbelievable place. Like, even the water there is so clear that the reflection of the mountain it seems to be pristine in the water as well. And the mountain itself, too, you can kind of scale it as you go. But in this case, you could see there's quite a bit of snow on the mountain in Lake Agnes. And again, because we're so much higher up than sea level, the lack of molecule collision limits our heat production. So because of that, it tends to be colder and colder. And it's interesting, when you're closer down, when you see lakes like Lake Louise, which is a famous example, it's almost always very, well, it's not frozen. And the higher up you go, the more and more lakes you tend to see which are frozen. So it's really interesting contrast from that point. Again, when we were going up here, I could tell that I was under a bit more stress, just because I don't hike that often. So maybe it's an exercise thing, but there's a good chance that the lack of oxygen also makes it more difficult, right? So the higher up you go, especially if you're doing like a 2 or 3 day hike in Banff, the lack of oxygen would likely suppress or start to depress your heart rate variability. And unless you encounter some really stressful activity that's going on up there, there's a good chance you might not notice unless you're looking for something like that. But we could definitely tell as we were going up. There were some people who were more nauseous, especially the higher and higher up we went, maybe 4,000 or 5,000 meters in elevation. And there was some levels of acute mountain sickness occurring in some individuals. People were really struggling at the very top, and it wasn't from conditioning. It was just a matter of not being used to this environment and not being used to having a lack of oxygen from that point as well. Yeah, so it was a really fun trip, and if you go, make sure you always monitor the elevation you're going at. Take an Apple Watch with you, and try to assess changes from your heart rate variability. So sit down at base level for 5 minutes, see where you're at. As you go up, and let's say you have about 10-15 minutes to just sit there, relax, bring yourself back to a resting state. Take another 5-minute recording, and again, see where you're at. And then keep going up. I mean, this isn't a perfect assessment by any way, but it does give you some type of indication as to what's happening with your heart rate variability. Unless, you're just really struggling physically to get up there, then there's a good chance that it's your lack of conditioning that's affecting your heart rate variability more than the altitude itself. Another classic example, and this one's a really fun one, is in Mexico City. Mexico City has a much higher elevation than most cities. It's roughly 2,200 to 2,300, right? 2,240 meters of elevation. And, there's a lot of occupational risk that comes with these kinds of elevations, right? So if you're doing a labor-intensive job, if you're flying in from where I'm in Canada, for example, or somewhere in the States to do some work in Mexico City, there's a good chance that you'll have to adjust to the atmosphere first. Or to the hypoxic conditions, I should say, compared to what the levels are like in the States or in Canada. And if you don't, there's a good chance that you can develop acute mountain sickness. If you go there for work and you're starting to notice that, hey, I'm feeling more nauseous than I normally do back home. I'm feeling a lot more tired really quick. I'm feeling a lot more sluggish. My heart feels like it's not beating as well as it should be. These kinds of things can be a good indicator of some kind of adaptation that your body's trying to go under. So it's just not used to the environment, but it's trying to adjust accordingly to the lack of oxygen. So, if you ever travel to Mexico City, especially if you have a extended stay or a plan to have an extended stay, it's important to consider that the altitude does make it a little bit difficult to complete everything as you normally would with respect to your physiological functioning. Now, there's the Olympics as well. In 1968 were actually held in Mexico. And of course, that represented a unique challenge because people were coming in to a highly elevated city without having acclimatized beforehand. And acclimatized, of course, acclimation essentially refers to coming to a city with elevation like this, and having your body adjust and auto-regulate for a period of time before you actually have to perform in that city. Okay, the amount of time that you should acclimate for, the research varies so much. Like, generally speaking, the longer the better, but it's not always the case, especially in athletes. Like, quite often you'd have to perform all around the world, right? So you might have 1 month a tournaments in one city, another month you might have a tournament in another city, and the elevations will vary quite often from city to city. So usually they say you want to live high and train low, meaning by living high you get a lot of the benefits of hypoxic exposure, and we'll talk about that in just a bit. But then you're also keeping your sport-specific demands in place by training in a lower altitude setting that's more reproducible compared to where you're going to be competing. And that's where Mexico City is an interesting paradox, just because it's got such a high elevation. And if you're competing in that kind of elevation, well, technically you should be acclimatizing to Mexico City only. And the 1968 Olympics, again, were very unique for this. There's a lot of anecdotal responses and papers, or I shouldn't say there's a lot of papers, there just wasn't as many back then. But a lot of anecdotal cases that suggested a higher prevalence of, lightheadedness, of fatigue, of shortness of breath, of nausea, like these kinds of problems that were occurring during the 1968 Olympics. In order to try and perform at your peak, perform at your best, you want to be as comfortable as you can. You want to be as adapted to the environment as you possibly can, especially in this level where even like a millisecond makes a big difference, right? When it comes to living at altitude, one benefit for athletes, or one thing that we tend to see quite often, outside of a purely medical context, more from a performance standpoint, so your kidneys actually produce something called erythropoietin. And erythropoietin is very interesting to consider, just because, when you're at altitude and you're adapting to it, erythropoietin production is enhanced in order to try and produce more red blood cells. Red blood cells carry oxygen. The more red blood cells you have, the more oxygen you can carry, and the more oxygen capacity you can have over time as well, right? So because of that, especially for endurance sports, which require a lot of metabolism at your targeted muscles. So from that standpoint, it becomes really, really important to have as much oxygen available as you possibly can. In a lot of other sports, in order to try and replicate some of the EPO production, there's blood doping, which of course comes with so many different health risks as well, right? So at least when you go to altitude, it's more of a natural way to produce more red blood cells, but even this immediate change, of course, comes with some level of health risk as well, right? So it's always important to keep measuring your, blood labs, your heart function, your kidney function, and just understand, how your body is changing to the hypoxic environment around you. So as far as altitude goes, this was a very brief, very general, non-specific overview. I think what I'll do next is start targeting specific responses in order to go into a more complex physiological adaptation response to altitude. But, if that's something you'd like, please let me know. Otherwise, thank you very much.